Alright, here's a coil of wire. There's 50 loops. They've given us the area already calculated for us, and it can rotate in the magnetic field B area. The coil is shown in three different orientations, here, here and here. In orientation A it's horizontal, vertical it's B, orientation C it's 45 degrees to the vertical. Which of the following is the value of the magnetic flux through the coil when it's in this one here? The magnetic field lines go from north to south in all of these pictures. And in the first one, because it's parallel to that field, the flux is 0. In the second one, it's fully 90 degrees, it catches the most field lines. The flux equals BA. Point A equals 2 times 0.02 equals 0.04 bar. And orientation C, obviously it's going to be somewhere between these two. So let's look at our options we've got. At C it's not 0. It's not 0.4 because that's what it is in B. It's definitely not bigger than B because B's got the most flux. Has to be this answer here. Right, the 50 turn coil is rotated from orientation A to B, so from 0 flux to full flux, and that's the time it takes. 0.15 seconds. Calculate the average EMF. This is Faraday's law. EMF equals negative N, change in flux, over change in time. Let's work out the change in flux over here. Equals flux final minus flux initial. So it changes from A to B. The final flux is 0.04. The initial flux is 0. So 0.04 minus 0 equals 0.04. So, what have we got? N. 50 turns means 50 loops, and that's our N. Negative 50 times the change in flux is 0.04 divided by 0.15 seconds, and that equals 13.3 volts, or negative 13.3 volts. If you didn't put the negative sign in, again, they're not worried about that. What they were looking for is that you understand and get the magnitude right for this one. So you could have had plus or minus 13.3, but they're happy with both.